Hello friends, welcome to our channel Tech on Target. In today's video, we are going to discuss a problem in Kubernetes and what solution Kubernetes is offering. Same video is available in Hindi language in our channel. If you prefer Hindi language, you can go. You will find link in the description. And let's start today's video. You can see in in my screen there is some traffic is coming. We can assume that it is a website and maybe some application or some any sites traffic is coming, and through LB plus Indus traffic is shifted or routed to different ports. These ports I have these maybe contain the same application or maybe contain different paths. We can see that this part is slash blog, about us, home tab, and the different kind of stuff is available. So if one pod is get failed or application inside the pod get failed, what we can do? So if we assume that our application is running in instance, and if application goes down, we can do monitoring over that, and we have to deploy we have to resolve that error. And there is no option that instead of that new VM will launched, we have to fix that, and we can make the auto scaling. And but how to fix that? We someone need to log in and fix that, or remove that particular VM. But in case of Kubernetes, we have some advantages, some solution which are out of the box, which are not possible in very difficult to achieve in VM structure. Like we have a pod. If application inside the pod is failing, so it can restart the pod. That means restart refers to deleting the pod and creating new pod. For that, we use the props to check the health of the applications. Application health is determined by the props. We have different props. First prop, we have the liveness prop. Liveness props is the only prop which can restart your pod. For example, if application inside pod got failed, and there must be a health check which is configured by your developer team, and they will provide to you. Upon on that particular health check, you will hit API every time. Frequency is set by you, and whenever this we not get response, according to the action will be taken. And with that prop, we have second prop, readiness prop. It's check the pod is ready to accept the traffic or not. Like if pod is not ready for the traffic, to hold the traffic, it will not add in the ingress pod or LB target group. In AWS we have target groups, so it will not add in the target group, for example. So it scan means you have two pods of same application. Third pod is going to auto scale because of the increase in traffic, but it will take some time. And once it is ready for the traffic, readiness probe give it's a green signal, and it's more about the readiness. It can't restart your pod. You are not able to restart the pod. To restart it, you have to configure the liveness probe. So third condition is coming here. One more probe we have. There are some pods, some application which are using the much resources, and they are heavy application. They take some time. For that, we have this startup probe. Startup probe what does? It disable the both liveness probe and readiness probe for particular time, up to which startup probe will work. Startup probe we configure only then where we have some kind of application and we don't want port restart because it is going to take some time. And if liveness prop failed in that particular period, it will restart your port and your application will go in a problem and it never come up. So I hope you are uh, you have understand the but why we use props, what are props, and what are the major types of props in Kubernetes and what they are work in, we can say, in theoretical way. So it is I think it's video number 7 for us. We have not covered the LB and ingress. We will do in later part of video. For today video, just understand that LB is a load balancer which maintain the load of the traffic, which maintain the load. It will distribute your load on your pod of same type. If you go to official website of the kubernetes.io, you will find the section for props. Before going to start the demo, I will like to show the content of my channel. We have videos on Azure, AWS, wazuh, and different stuffs is over there. Kubernetes in Hindi and English language both are there. You can visit our channel, and if you have any feedback, please share with us. And if someone is reading Kubernetes, and you can share the video with him. Hopefully, he will get benefited from our videos. So let's start today demo. That's our first file. We are going to configure the liveness prod. What this file is doing, it is simple manifest file. You will find this file or this particular example on Kubernetes official doc. So we are creating a kind of pod and giving it's a label, and it is just giving its the name of liveness exact, and its specification we are giving the name and image. It is using the public image of BusyBox, and we are passing the arguments. What in the argument we are passing we are giving it as a shell /bin/sh and then -c. We are providing the commands which we are saying the touch /temp/healthy. That's it will create a healthy file in /temp, and then it will go in sleep mode for 30 seconds, and after that it will read that file. Okay, it is a simple Linux command which is creating the file, making your system to sleep, and then deleting that particular file. On that we are creating the liveness probe, and what is it's doing, it's doing cat or reading that file. It's doing cat the particular file. When we do the cat to particular file to read the content of the file, if this file should be present over there. If file is not present there, you will have issue and your command will fail and you got error. So we are passing here two parameters: initial delay second and period seconds 5. So whenever we launch the pod, it will wait for first 5 seconds and then it will launch. Then it after that 5 seconds means a total of 10 seconds. After total of 10 seconds, it will check the first probe, and with the frequency of 5 seconds, it will continuously check the liveness probe. So I hope you are very much clear with the manifest file of liveness probe. Let's create this object of pod with liveness probe. You know very well how we can create the objects, and we are creating this under particular namespace. So our pod is created. Let's kubectl get pods and check its status. We have to pass the namespaces with it. Yeah, you can see the liveness exact board is in a ready state and status is running. How we can check the events? We can use describe. It will very help you to understand, like kubectl describe ports liveness exact hyphen and test. You can see that it's successfully assigned this particular node uh, to installation port. Then it's pulled the image and created liveness and started container. Now you can check that it's after 30 seconds it's giving that is 30 to 37 seconds it in a good position. And after that, after 30 seconds, which liveness probe check happened, it found that file is not there, so it got failed. What we have given arguments and instruction in our manifest file according to that, and what we have studied earlier, liveness probe, if pod application got failed, its health check got failed, it will restart the pod. And you can see that uh, liveness probe got failed, then container liveness probe will be restarted. If it is restarted, restart just mean pod got created and new pod will get created. You can see that it's again pull the image and create the container and start the container, and successfully pulled image and container is in a running condition. So all the events which are occurring, either you can exect it. Meanwhile, we will check the ports. Now you can see that it is in one by one state, that it is in ready state, but you can see the restart one. It's get restarted 59 seconds ago, and you will find uh, every 30 second 30 or 35 second it will got fail, and whenever it got fail, liveness probe will make it to restart. In that way, we can make our application healthy by using the liveness probe. Means you have a Java application of your website, and it will got failed due to some, and you configure some HTTP endpoint over there, health check point over there, and your liveness probe continuously ping it. And whenever ping response got failed and not come, it will just restart your I think it is just restart your container. Means you will create new pod, and on your pod new container will be created and your application will come live again. So that was the case of simple demonstration of liveness probe with the using simple Linux commands. Now we can move to other probes, and we can configure here the liveness probe of HTTP of kind. It's we can most of the cases you have some HTTP or HTTPS application. How you can configure the health probe there, that we will see. That's liveness probe HTTP get we are using. We are giving its path /health. That /health path will be given to you by your uh, organization team, developer team will configure that particular health probe. You don't have much to worry about that. They have to configure that to make their application manageable. And you can see that we are giving a port 8080, and if I tell you more what it's doing, it's using a function under under that we have a function of /health. For first 10 seconds it will work fine, it will give you response of 200, which is a good response, and application will become live. And after that it will going to give you the bad response, which make your application lead to down. You know, 200 to 300, your status code, when it's coming, it's considered as a good status code. But whenever it's go above that, and it will consider as a bad response, and we can assume that your application is got down. So whenever your application is got down because of any reason, first task is the automation, that it's get fault get replaced and your application will be again live. So let's create this particular object and check what its status. I hope font is not the issue. Font is very much clear to you. kubectl create -f. That's, if you do kubectl get port -n test, yeah, you can see that here liveness HTTP is ready and running state, and there is a no restart. Initial delay second is 3, and after this 3, after all 3 seconds, it will do liveness check. So we can make it's describe it. We will describe it for better understanding. It will take restart much frequent than my previous one. I think, yeah, describe pod, we have to mention which kind of object it is. That here you can check 64 seconds successfully pulled the image, created the container, started the container, then successfully pulled image again, pulling image liveness, because of the liveness probe failed with the status code 500, that one, because whenever it got the response code with bad reputation, it will consider your application down and restart your pod or container. If you see here, it had taken 3 times restart. Sorry, it's taking restart because it's getting failed over 10 seconds. Earlier we have, if you remember, earlier we have the timing of 30 seconds. Now in the TCP liveness YAML, we have we will actually, video is getting lengthy over here. So in this particular YAML file, we are going to implement all the 3 use case: liveness, readiness, and startup pro. If you can see that we are having a geo proxy image, which is the public image, and we are checking its TCP connection. It will listen on 8080. Readiness port, we have given the port 8080 with initial delay 5 seconds, and after that with the interval of 10 seconds, it will check for readiness probe. Same we are doing for liveness probe. In the liveness probe, we are giving the same TCP socket because container port is the 8080 only, and initial delay second is 5, and same per second health check is 10 seconds. Status probe TCP socket, here is the port will remain same 8080 with initial delay second 30 and period seconds 20. So what we are doing him 30 seconds, actually it will wait for your application or your port to came up, because there are some certain cases like you have a very heavy application which take time to load, and if it takes some time, maybe take much time because of any issue due to slow internet or any other issue, it will not let to restart or failed your pod. So we are giving the sufficient time of 30 seconds, and this time may vary according to your application or your use case, what kind of application you have and how much time it takes. That's your particular use case. You have to take care of that, what time your application can take up to, and after what time you are going to check that. So whenever when it's came up, if you see that its time is 30 second, and others time is 5 second, but others times readiness probe time start when it's came up and its 30 second are gone, are completed, not gone, are completed. After that it can take. You can see that uh, after the near about 45 seconds it's given us the ready status. um, Before that it not given us the status because of the particular startup probe. That is the use case of the startup probe. If we describe the pod, let's describe, because in the particular case our container is listening on 8080, so no probe will be no probe will have issue, and our container will not get restarted. To check our probes they are working properly, we have to play around them, make some changes to observe the result, to find the differentiate what is going on. So first we delete our current current objects, and we can create our. So we just focus on our two proofs, liveness and readiness, how they are working. uh, in earlier they have given the status around 45 second. Now you can see I have just commented out the startup probe. Now you can see it given us the ready status within 15 second, because we have initial delay of 5, and after that 10 duration of 10 second it checks for probes. So that's why under 15 seconds it's given us the result of working. That's your containers are working. So that's the first thing I want to show you. Now what I have done, I have made the port down like it's I have set it on 8081. So we are not going because image is not listening, container is not listening on 8081 port, your probes will get failed. So let's see uh, what happened. Yeah, it's created. 8 seconds are gone and it's showing us the result of it's showing us the result of that in 0 by 1 second. It's okay. Now we are describe it. Now we are here, successfully assigned, okay, container bold image, and after 20 seconds it's got failed. It's saying that the readiness probe failed. After that our liveness probe will also fail. And you know very well that when liveness got failed, what will happen? It restart the pod. Let's kubectl list the pods in the test namespace. You can see here the we are seeing that the liveness and readiness both got failed, and our pod got restart 29 seconds ago. If we delete the I think it is clear to you. Let's delete the liveness, uh, these particular objects, and we correct the liveness probe. We are just doing this stuff to make you observe or to experience the difference. Now let's create it. Create -f tcp liveness.yaml. Now see, we will do the list of pods. They are not in the ready state. It will take around initial of starter probe time. After that, it will check for health. So our only probe which will got failed this time is the redness. Yeah, redness probe is got failed, but if you list the pod, you will see it's not taking the restart. So that is the for today. Hope you like the video, and if you continuously list, it will not got restart. If you have any suggestion, any feedback for us, please share, comment it out, subscribe, like. Bye.